the principle of gravimetric analysis. For the first, to identify the insoluble form of analyte. The analyte soluble form turn into analyte insoluble form. After that, number 2 is to separate the analyte from any constituent that may interfere. And for the next is wash the precipitate to free impurities and co-precipitant. After that, dry the precipitate. And for the last is convert the precipitate to reliable weighing form. This is advantage and disadvantage for gravimetric analysis. For advantage, we can look for the first point is no calibration needed. And for the second, no standardization required. And for the third is high degree of accuracy and precise. And for the last is inexpensive equipment. And for the disadvantage, we can look for the first point is require a long experimental hour, especially at heating and drying. And for the second is provide the analysis of a single element or a limited group of elements. There is two types of gravimetric analysis. For the first is precipitation gravimetric. The meaning of this gravimetric is the analyte is separate from a solution of the sample as a precipitant and is converted to a compound of known composition that can be weighed. And for this gravimetric is volatilization gravimetric. The meaning is the analyte is separate from other constituents of a sample by conversion to a gas of known composition was may serve as a measure of the analyte concentration.
Next, for my part, I will explain about the methodology in gravimetric analysis. There are 6 types in gravimetric analysis, which is number 1 is preliminary treatment, precipitation, filtering and washing off, drying, weighing and calculation. For step number 1, we need to weigh 1.00 gram of fertilizer and dissolve it into 100 ml of distilled water. For step number 2, add 10 ml of 10% of BaCl2 solution in the beaker and slowly stirring the solution. Next, allow the mixture to stand for 30 minutes to complete precipitation of BaSO4. For step number 4, filter the mixture using pre-weight filter paper and make sure do it slowly to avoid the solution overflow come out from the filter funnel. For step number 5, dry the filter paper with BaSO4 in oven at 110 degrees Celsius with constant wick. For the last step, we need to weigh the dry filter paper plus BaSO4 in analytic balance and we can proceed to the calculation.
I will continue to present the example of the result we can obtain from the experiment. So the first thing we will do is going to weigh the mass of the filter paper in an analytical balance. So the mass of the filter paper we obtain is 0.982 grams. Next, we need to count the mass of the filter paper with barium sulfate, which means we need to put the barium sulfate onto the filter paper and then we weigh again using analytical balance. So the mass we obtain is 1.582 grams. Next, we need to find the mass of the barium sulfate because we cannot find it directly or weigh the barium sulfate directly on the analytical balance. So we will need to minus the mass of filter paper plus barium sulfate with the mass of the filter paper. So we are going to obtain 0.6 gram for the mass of the barium sulfate. So now we already obtained the mass of the barium sulfate. Now we need to find the mole for the barium sulfate. So to find the mole for barium sulfate, we can use the formula mole equal to mass over molar mass. So molar mass for barium sulfate is 233.39 gram over mole. So we can find the mole for barium sulfate through this formula. Then after we obtain the mole for barium sulfate, we will compare it with the mole of sulfate through the equation, which is barium sulfate equals to barium ion and sulfate ion. So there we get that the comparison of the mole is 1 mole over 1 mole. So the mole for barium sulfate is the same as the mole of sulfate. So after we obtain the mole, we need to find the mass for the sulfate. So to find the mass of the sulfate, we will use the formula mass equals to mole times with molar mass. So as stated on the slide, so 0.6 gram barium sulfate times with 96.06 gram over mole sulfate divided with 233.39 gram over mole, which is the molar mass for the barium sulfate. So the final answer we obtain for the mass of the sulfate is 0.247 gram. Lastly, after we obtain the mass for the sulfate, we will need to find the percentage of sulfate. So to find the percentage of the sulfate, we will use the formula weight over weight times 100. So the weight of the sulfate, which is 0.247 gram, we will divide it with the mass of the sample, which is 1 gram. And then we will times it with 100%. And the final answer for the percentage of the sulfate we obtain is 24.7% weight over weight.
Gravimetric analysis, we successfully determine the amount of phosphorus present in a fertilizer sample by precipitating it as barium sulfate. We begin by dissolving 1 gram of the fertilizer in distilled water and adding barium chloride to form a solid precipitate of barium sulfate, which was then filtered, dried and weighed. After careful drying with constant weight, we found the mass of barium sulfate to be 0.6 grams. This indicates the presence of phosphorus in the fertilizer as barium sulfate forms from the reaction with phosphate ions. This method proved to be a reliable and accurate approach for quantifying phosphorus content in agricultural products. That is all from us. Thank you.